When you lie down on the grass on a summer night and gaze up at the brilliant Milky Way spanning the sky, do you feel a shock that resonates from the depths of your soul? Within our visible range, we can see about 2,500 stars. But this is merely 100 millionth of the Milky Way. In fact, the Milky Way contains between 100 billion and 400 billion stars. And within the entire observable universe, there are as many as 2 trillion galaxies. Every single point of light could be a star system just like our Sun. Even if we take the most conservative estimates, assuming only 5% of stars have Earth-like planets, assuming only 1% of those develop life, and assuming only 1 in 10,000 of those evolve into intelligent civilizations, then, in the Milky Way alone, there should be at least several thousand, perhaps even tens of thousands, of advanced civilizations capable of interstellar communication. Yet, no matter how many years we press our ears, our radio telescopes, against the chest of the universe, or how many business cards like the Voyager probes we scatter into deep space, the response we receive is always the same, a deathly silence. No signals, no spaceships, no traces of megastructures. This is the famous Fermi Paradox. When Enrico Fermi casually asked, "Where is everybody?" in 1950, he unleashed a question that still hangs over humanity like the sword of Damocles. The logic behind it is terrifying. The universe is 13.8 billion years old, while Earth is only 4.5 billion. If just one civilization emerged a few hundred million years before us, even without lightspeed travel, they could have colonized the entire galaxy in just a few million years using von Neumann probes, self-replicating robots. On a cosmic timescale, a few million years is merely the blink of an eye. This means aliens should have been here long ago. Their ships should be buzzing over our heads as frequently as airplanes do today. But the reality is, we haven't seen them, nor have we seen their debris. Why? Today, we will deep dive into the possibilities behind this silence. Each one is enough to shatter your worldview. The first explanation is perhaps the loneliest. We are special. This is the rare Earth hypothesis. Perhaps the birth of life is not as easy as we imagine. It requires a series of miraculous accidents stacked on top of one another. First, you need a planet in the Goldilocks zone. Not too hot to boil water, not too cold to freeze it. But that's just the entry ticket. You also need a big brother like Jupiter. Jupiter's massive gravity acts like a vacuum cleaner, sucking up most of the comets and asteroids that might otherwise bombard Earth. Without Jupiter's protection, Earth might face an extinction-level impact every few thousand years, making the evolution of complex life impossible. Second, we need the Moon. This satellite, abnormally large relative to its host planet, locks Earth's axial tilt in place, giving us stable seasons. Without the Moon, Earth's tilt would wobble chaotically like a spinning top, resulting in a climate too violent for life to endure. There's even plate tectonics. Earth is the only known planet in the solar system with active crustal movement. This not only shapes our continents but, more importantly, sustains the carbon cycle and regulates atmospheric temperature. If any link in this long chain were missing, life might have remained nothing more than a soup of single-celled bacteria. This theory suggests that while the universe is vast, only Earth won the lottery to collect all these conditions. We are not just the only civilization in the Milky Way, we might be the only life. Does this loneliness send a chill down your spine? Hold on, because the next theory is far scarier than loneliness. If Earth isn't special, and if life is common, why are there no advanced civilizations? Robin Hansen's Great Filter Theory offers a suffocating answer. In the evolution from dead matter to a stellar civilization, there is a hurdle, or several, that is nearly impossible to cross. It's like a brutal cosmic game. The vast majority of life forms are ruthlessly eliminated when they reach this level. The critical question is the Great Filter behind us, or ahead of us? If the filter is behind us, that's good news. Perhaps the leap from inorganic matter to the first self-replicating cell, the origin of life itself, was that filter. Maybe the probability is so astronomically low that we are the only ones in the universe who made it. This means we are safe, we are the chosen ones, and our future is bright. Or perhaps, the jump from simple prokaryotes to complex eukaryotes, or from single-celled to multicellular organisms, is the step that traps 99.99% of planets. Life appeared early on Earth, but single-celled organisms ruled for billions of years before the Cambrian explosion. This suggests that this step was incredibly difficult to take. But the worst-case scenario is that the Great Filter lies ahead of us. This implies that evolving intelligence isn't hard, and developing technology isn't hard. The hard part is surviving. Perhaps every civilization that reaches the atomic or information age inevitably heads towards self-destruction. Look at ourselves. We've had nuclear weapons for less than a century, and we've already stood on the brink of nuclear war countless times. Beyond nuclear war, there is runaway artificial intelligence, superviruses from genetic engineering, or ecological collapse from resource exhaustion. Perhaps it is a cosmic law. Once a civilization masters the power to destroy its planet, its wisdom and morality fail to keep pace with its technology. Like a child playing with fire, it eventually burns down its own cradle. This is why finding bacteria on Mars would be the worst news in human history. If life evolved independently on a neighbor like Mars, it proves life isn't rare, and the filter isn't behind us. That means it is waiting ahead of us. As philosopher Nick Bostrom said, "The silence of the night sky is golden." Of course, aside from self-destruction, there is an explanation popularized by the sci-fi novel The Three-Body Problem, the dark forest theory. The universe is a dark forest, and every civilization is an armed hunter. Because of the chain of suspicion, you never know if the other is benevolent or malicious. The safest option is, shoot first, ask questions never. Under this theory, the universe is quiet not because it's empty, but because everyone has learned to play dead. Those naive civilizations, like humans, who shout "I am here" into the cosmos may have already been wiped out, or are currently being targeted. We might still be alive simply because we are too small, and our voice hasn't traveled far enough yet. Then there is a milder, yet equally unsettling theory, the zoo hypothesis. Higher civilizations have found us long ago, but they choose not to interfere. Just as we establish nature reserves to observe lions and antelopes, they have designated Earth as a primitive civilization preserve. Perhaps our laws of physics, the stars we see, and even our understanding of the universe are merely a set they designed. They watch us quietly, our wars, our plagues, our love and hate, just as we watch ants fighting in a glass tank. If this is true, what are they waiting for? For us to evolve? Or are they waiting for us to fatten up before the harvest? Finally, let's expand our minds even further. Maybe we can't find them because our method of searching is fundamentally wrong. We keep looking for radio waves and physical structures like Dyson spheres. But according to the Kardashev scale, once a civilization moves past a Type 2 civilization and becomes Type 3, their existence might transcend our comprehension. For a civilization capable of harnessing the energy of an entire galaxy, perhaps biology has been discarded. Consciousness might be uploaded to quantum computers, existing in a virtual paradise. Or perhaps they have mastered the ability to modify physical constants, folding themselves into microscopic higher dimensions, no longer interfering with the macroscopic universe. Just as an ant can never comprehend the highway humans are building beside it, it only sees a strange rock. We might not even qualify as ants to an advanced civilization. We might just be roadside bacteria. The radio waves we desperately transmit might seem as laughable to them as a caveman trying to contact a smartphone user with smoke signals. Regardless of the answer, the Fermi Paradox pushes humanity to the edge of a philosophical cliff. If the road ahead is empty, then we bear the heavy burden of spreading the fire of life across the galaxy. We are the sole carriers of cosmic consciousness, a responsibility both heavy and sacred. If it is the great filter, then we must remain vigilant. We must set aside our arrogance, handle the sword of technology with caution, and strive to be the lucky survivors. If it is the dark forest, then we must learn to hide and strengthen ourselves. Arthur C. Clarke once said, "Two possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying. But fear should not stop us. It is this awe of the unknown that drives us to build more powerful telescopes and fly deeper into space." Next time you look up at the stars and see that endless darkness and silence, remember, perhaps the silence is not emptiness, but a form of waiting. Waiting for us to grow up. Waiting for us to understand the whispers crossing space-time. Why do you think we haven't found aliens? Leave your thoughts in the comments below. See you in the next cosmic exploration.